In this part, we'll talk about multi-conditions, particularly when we use if, else if, and nested if statements. Sometimes we might need to consider multiple conditions in order to make a decision. That is why we have these multiple conditions mechanisms that allows us to check for one condition to multiple conditions. For example, we might want to find one condition, and if that is true, we shall terminate the process immediately. However, if one condition is not true, we should be allowed to go and search for one condition that allows us to find a solution. Worst case scenario, we can always find the else statement that allows us to execute just in case all of the previous conditions never met. There's multiple ways to do this. Java allows us to use the if, else, if statement and also nested statements. Nested if statement allows us to group multiple conditions inside of one if statement, permitting to use something called separation of duties. We just need to be careful how we can establish logical errors. Logical errors are not syntax or runtime errors. They are errors that relates more in the logic we develop our program while we code it. Let us consider the same example of weather checker. In this case, we're going to check if the temperature is greater than or equal to 80, but we need to be careful when we exceed one temperature. For example, in El Paso, Texas, 110 degrees might be a little bit too hot to be outside. That's where we suggest do not go outside in case the temperature is greater than or equal to 110. Otherwise, we can just wear shorts and t-shirt. In case the temperature is not greater than or equal to 80, we're going to consider if the temperature is cold. If it's cold, we just need to be careful. If it's less than or equal to 30, maybe it's not a good idea to go outside. However, if it's not true, then maybe we can just wear some jeans and jacket. Let's code this in a program. Let us consider our previous example of weather checker. This time we're going to use a multiple if statement to consider the extreme temperature. We're going to address the logical error that we discussed. After the temperature greater than or equal to 80, we need to be careful. A common error is to just include another condition if the temperature is greater than 110. To print do not go outside. In similar fashion, we can do the one from the cold temperature. If it's smaller than or equal to 30, we should not go outside. Let's save, compile, and run this program to see our logical error. If I enter the temperature is 80, we expect to have wear shorts and t-shirt. And indeed, we're going to have that. However, check what's going to happen. We're going to print wear shorts and t-shirt, but also wear pants and jacket. Let's analyze what's happening here. In our code, when we arrive at temperature, this expression is true. 80 is greater than and equal to 80. So this condition is true. Therefore, Java will execute this line. But when it gets out, Java will check this condition as well. It is false. That is greater than or equal to 110. Because this is false, Java will already check that the previous condition, the one that is highlighted here, is false. So it will go to the next conditions, which it happens to be also false. 80 is not less than or equal to 30. So it will jump to the else. In case the previous condition is false, then you arrive to the wear pants and jacket, which is what we have. This is considered to be a logical error because of the way we state the actual conditions. How do we fix this? One way to address this problem is by include else if. Else if statements allows us to go and check more conditions just in case one condition was not true. In other words, if the if statement is not true, then it allows us to go and check individually to the following conditions. And if the previous conditions are not true, then we can arrive to the else. This fixes our problem at some extent, but not entirely. Check this out. I'm gonna clear my screen, compile, and run. If we enter 80, we're gonna get wear shorts and t-shirt. However, if I enter 120 degrees, look what's gonna happen. It's gonna suggest to wear shorts and t-shirt. And that is because in our code, the temperature that we're providing, 120 degrees, is indeed greater than or equal than 80. So this logical error happens because we are including the smallest quantity before the largest quantity. A solution is to include the largest quantity before anything else. If we enter 120 degrees, it's going to address do not go outside. If we enter 80 degrees, wear some shorts and t-shirt. 60 degrees, wear some pants and jacket. And 24 degrees, do not go outside. For the next variations, we're going to do something slightly different. We're going to use nested statements. Nested if statement allows us to group similar conditions together, allowing to use separation of duties. Separation of duties is a software engineering principle where you identify similar tasks and join them together, which allows us better debugging, which is identify errors or provide maintenance in the future. It also allows us to simplify a logic error. If you remember our algorithm, here we're going to check for hot and cold temperature. Hot temperatures, we know it starts from greater than or equal to 80 degrees, and cold temperatures are the remaining. We can depict this one by having an if statement if the temperature is greater than or equal to 80. If that is the case, if it's true, we still have to check if the temperature is greater than or equals to 110 in order to suggest to not go outside. But if it's not true, then we can just simply wear some shorts and t-shirts. In the else statement, we check if this temperature is less than or equal to 30 in order to suggest to not go outside. But if it's not true, then we can just suggest to wear some jeans and jacket. So in this code, we just want to know hot temperatures and cold temperatures. The if statement will be in charge of the hot temperatures, and the else will be in charge of the cold temperatures. Notice that we have an if and an else statement. Everything related with hot temperatures will be inside of the if statement. Everything related with the cold temperatures remaining will be in charge of the else. Inside of the if statement, we're going to create the nested if statement that will check if the temperature is greater than or equal to 110 degrees. Is that the case, we can print do not go outside. Otherwise, wear some shorts and t-shirt. Now let's go to the cold temperature. In the cold temperature, we need to check if the temperature does not go below 30 degrees. If that is the case, we can print do not go outside. But if not, we can simply print wear some pants and jacket. At this point, we have if statements controlling the hot temperatures, else statement controlling the cold temperatures. At the end of the program, we only have the curly bracket that closes the scope of the main and the scope of the class. This is a good opportunity to make this code a little bit simpler. Let's start by printing print instead of print line. This will allow us to print in the same line rather to go to the next line. Another thing that you can get away in Java is that in case the if statement has only one statement inside of the scope, you can get away without using the curly brackets. It means that you don't need curly brackets here, 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 and here. We don't really recommend to do this unless you have some experience later on of programming. I know right now it feels more comfortable and more clean without including any curly brackets, but please try to use them as a best practice to keep everything enclosed. Eventually, you can get an else without if because you forgot to include those curly brackets. Let's save and compile and run this program. If we enter 100 degrees, we will go into the if statement when the temperature is greater than or equal to 80. And then we're going to go inside of the nested if statement where we're going to check if the temperature is greater than or equal to 110. 100 is not greater than or equal to 110, so that's where we're going to go to the else and print wear shorts and t-shirt. We terminate our program immediately because everything remains in the if statement and there's no need to go to the else. We run this program again. Suppose the temperature is 120 degrees. In that case, 120, it is indeed greater than or equal to 80, so we get inside of the if statement. But not only that, we still have to check in the nested if statement. Is 120 degrees greater than or equal to 110, which is indeed true. So we're going to print do not go outside. Let's deal with cold temperatures. Suppose that we deal with 70 degrees. The first thing is that we're going to check if 70 degrees is greater than or equal to 80, which is indeed false. So we jump to the else. Now we're dealing with cold temperatures. Nested if statement inside of the else will ask us if 70 is less than or equal to 30, which is not true. So therefore we jump to the else, generating wear some pants and jacket. Let's try an extreme temperature, for example 24 degrees. Again, first thing we do in the program is to check if the temperature is greater than or equal to 80, which is false, jumping directly into the else statement. The first condition inside of the else, nested if, will check if 24 is less than or equal to 30, which is indeed true. So do not go outside.